Good afternoon, viewers. Welcome back to Easy Mathematics. We thank God for another wonderful day and a beautiful weekend. As we said, today we'll be looking at Basic 9. Last week we looked at perfect square and perfect numbers in Basic 8. Today let us look at rational and irrational numbers in Basic 9. Now, with this, we want to look at the relationship between numbers or the relationship between rational numbers. Good. Now, let's look at the first one, which is rational numbers. Now, rational numbers are numbers which can always be written as a common fraction or as a vulgar. Now, once a number can be written as a common fraction or as a fraction, then that number is a rational number. That is, an integer divided by another integer in the form a over b. So when I divide an integer by another integer to get a form as a over b, where the a is an integer, the b is also an integer, but the b shouldn't be 0. So if a number will be a rational number, then that number should or can be written in a what? In a form of a fraction, that is a over b. Once that number can be written as a common fraction, then that number is a rational number. Good. Now let's look at some examples of rational numbers. Now all rational numbers falls under certain given names. Now we have a proper fraction. Now we know that a proper fraction is when the numerator is less than the denominator. So all proper fractions are rational numbers. So we can give example and say 2 over 5 is a rational number because you have it as 2 over something, that is an integer over an integer. So we can say 10 over 21, etc. So all proper fractions are rational numbers. Then we also have improper fraction. Improper fraction, that is the opposite of proper fraction. So we have 5 over 2, we have, let's say, 10 over 7. They are all rational numbers. So rational numbers are numbers that can be written as a common fraction. So even if it is a decimal and that decimal can be written as a common fraction, then that common fraction or that decimal is a rational number. Then we have mixed fraction. That is a fraction with a whole number and a fractional part. So if I have 3 whole number, 1 over 6, 10 whole number, 1 over 8. It is also a what? A rational number. Now you can write this as a decimal. You can change it into decimal. You can also change this into what? Into decimal. So once a decimal can be written in a common fraction form or can take the format of a common fraction, then that number is a rational number. Then we have integers. Now integers are positive and negative whole numbers. Let's take the key word here, whole numbers. We will make very good use of the word whole numbers. Now all integers happens to be what? Rational number. Now remember that integers are positive and negative whole numbers. But we also know that under fraction, every whole number is over 1. So if an integer is a rational number, then the integer, let's say negative 7, is the same as negative 7 over 1, which happens to be a fraction. Then we can also say negative 10, which is also over 1, or a positive value, let's say 21, which is also what? Over 1. Now since it has taken the form of a over b, where the b is not 0, then this number is a rational number. So all integers are rational numbers because of the fact that every every whole number is over 1, which makes it an what? An integer. So we've mentioned some examples of rational numbers. We said proper fractions, improper fractions, mixed fractions, integers. Let's take very good note of that. Integers are positive and negative whole numbers. Now, whole numbers start from 0. Let's take good note of that. Also on that. Whole numbers start from 0. So we have 0, 1, 2, 3, 4, going. That is it. Then we also have another example of rational number, which is terminating decimals. Terminating decimals. When we say terminating decimals are decimals that has an end. Okay, the decimal is having an end. If the decimal is having an end, then we say that this decimal is a terminating decimal. So an example is 0.5. 0.5 has an end. So this can give us in fraction as 5 over 10, which is what? 1 over 2. So all fractions that are having end. So we have 0.731. So when we say terminating decimals, they are decimals that has an end, or a decimal whose end can be seen or found. Then we call that decimal a terminating decimal. So all terminating decimals are also rational numbers. Why? Because we can write them as a what? As a common fraction. Because we said a rational number is a number that can be written as a common fraction. So once a number can be written as a common fraction, then that number is a rational number. Let's take good note of that. It's a rational number. So we can write, so this one, which is the 0.731, can be written as a fraction as 731 over 1000. So since the fraction can be written as a common fraction with a numerator and a denominator, then that fraction happens to be a rational number. Good. It's very simple to differentiate between a rational number and irrational number based on the definition we are telling or discovering. Then we have the recurring decimals or repeating decimals. Now, recurring decimals are decimals whose numbers after the decimal point repeat itself in order forever. It is in a certain pattern or a certain sequence. It repeats itself. So if I take a decimal like 0.3, or let's say 3 over 10, this decimal, you notice that this fraction, if I try to change it into decimal, what am I going to get? I am going to get 0.33333333333 infinity. It has no end. So we say that 0.3 is, with a dot on top, is a recurring decimal. It has what? No end. It goes forever. But it is in a certain order. It is in a certain order. So once it is in a certain order, then that number, that decimal, is a recurring decimal. And it is a recurring decimal, so it happens to be what? A rational number. This is because the number can be written as a common fraction. Once it can be written as a common fraction, then it is a what? A rational number. Good. Let's take the other example. If you have a decimal like 0.123, 123, 123, and that 123 follows and continues. You see, it is repeating itself. It is recurring. So once it is recurring and it is forever, we say it is a recurring decimal. So we have 0.123, 123, 123. So with this pattern, we can predict the next numbers. So 123, 123. It goes on forever and ever. That is what? Recurring decimals. And we should also know that with recurring decimals, because they can be written as a common fraction, then they are rational numbers. So all decimals that are having the numbers after the decimal point to be in a repetition order that do not end or has no end are called what? Reoccurring or recurring decimals, or we say repeating decimals. But for terminating decimals, they are decimals with end. They have end. So if you take a fraction like 0.75, it has an end. 3/4. If you change 3/4 into decimals, what you are getting happens to be what? 3/4. So the 3/4, which is the same as the 3/4, which is the same as 0.75, this is a terminating decimal. It has an end. But with the one that has no end, that you notice that it keeps on going in a certain order. In a certain order. If it is not going in a certain order, then that one is different. But once it is going in a certain order, then we call it a what? A recurring decimals. And all these are examples of rational numbers. So now we can know what rational numbers are. And we can be asked, especially in section A, that which of the numbers below are or is rational number. Improper fraction, mixed fraction, proper fraction, integers, terminating decimals, and recurring decimals are all rational numbers. Good. Now let's look at the opposite of rational numbers, being irrational numbers. Irrational numbers are numbers which are not rational. And when we say they are not rational, it means it cannot be written as a common fraction. You can't write it as A/B. So it says that cannot be written as a what? As a common fraction. Example, we call this the square root of 2 or sec2. So this happens to be what? An irrational number, because we cannot write this as something over something. Now, when you take the 22/7, changing this 22/7 will give you a decimal, whereby the decimal you will find out that it is 3.142 something, but not even in a certain order and has no end. So when we say irrational, it cannot be written as a common fraction. Now, changing this into decimal, you know that this happens not to be what? A common fraction. Now, the 22/7 is an approximation of what we call pi, which very soon we'll know what it is, which is called what? Pi. And it has been estimated or approximated. Okay, it has been approximated to be 22/7. That means we don't know the exact value. So it says that there are also numbers that you cannot find their exact values. If it is 0.45671, you can't find it. It continues. It is forever. And even not in a certain word pattern. And we call them what? Irrational numbers. So it says that the square root of all prime numbers are irrational numbers. All prime numbers. The numbers with two factors. They are all numbers with two factors. So with them, their square roots makes the irrational number. Remember, we said prime numbers, because the square root of some odd numbers is not a prime number, or the cube root of some numbers, which happens to be odd numbers, are not irrational. Good. So other examples of irrational numbers, we have numbers that are what? Non-repeating or non-terminating numbers. The non-repeating or the non-recurring or the non-terminating, it has no end, which of course too, it is not in a certain order. So look at this example. You have here, it says 0.123, 123, 3, 3, 2, 1, 3, 2, 1. You cannot predict the next one, whether it's going to be 1, 2, 3 or 3, 2, 1, provided there is what? Double dot here. So a number that's, when we say non-terminating, it means it has no end. And the non-repetition or the non-repeating numbers, the numbers after the decimal point are not in a certain order. Like this one that you can see. With this one, it is 0.3333333. So you can predict that this one is 3, and this one is 3 in that order. This one too. 1, 2, 3, 1, 2, 3, 1, 2, 3. We can predict and know that the next numbers are 1, 2, 3, 1, 2, 3. So such numbers, they are irrational. But with the numbers that you can see that after the decimal point, it's 0, 9, 0, 9, 0, 9. So then this is what? It is a recurring number, which is therefore a what? A decimal. Now there is a way of converting recurring decimals and other non-recurring decimals into recurring decimals into common fraction. There is a way. But today we have to look at the relationship between rational numbers. Okay, that is what we are looking at. So what we should know is that all recurring numbers, terminating recurring decimals, terminating decimals, integers, mixed fraction, improper fraction, proper fraction, they are all rational numbers. Why? Because they can be written in or as a common fraction. So the ones that they cannot be written as a common fraction, you can't write them as a common fraction, is what we call irrational number. So we should know the difference between these two. Now we'll come back to this and we'll look at the question here, or let's even look at it. It says that sort out the following under rational or irrational numbers. So remember, we said rational numbers are numbers that can be written as a common what? Fraction. We have the proper, improper, mixed, integers, terminating, and recurring. They are rational. So all these numbers or these fractions are rational. Apart from that, there is no rational anywhere. Simple as well as that. Good. So let's look at the first one. You have 3.2222. Now looking at it, 2222222. We can easily predict the next number. You can see that it is recurring. So because it is a recurring decimal, then this fraction with the next 3 means that there are some that continue. So with this, we can say this is what is a rational number. Good. Now let's come to this one. Number 2, 16.213489. It is not in a certain order, and moreover, it is not terminating. So once that it's not repeating itself after the decimal point, then that should tell you that this is what? Irrational number. Irrational what? Number. Then the next one, you have 0.431431. What do you think will be the next numbers? You see, we have 3 dots after the number telling you that it continues, or we can write O. So looking at how the numbers are repeating itself, then this is what? A rational number, which makes this decimal a recurring decimal. Then we have the 4. Now look at the number 4. You have 0.142857. 142,857. What do you think will be the next number? It's also going to be 142,857, which makes it a what? A rational number. Look at the last one. You have 0.0909090909. So since it is repeating itself, it is in a certain pattern. After the decimal point, it's a rational number. Now let us look at this one, which, let's ask ourselves, is it a rational number or not a rational number? 0.11991119119 let's say 911919. Let's consider or check if this number is irrational number. If it is irrational number, Comment it on the section, or just write to us on the section, comment section. Let us know that it's rational or irrational. Look at the way it is following. Look at the pattern. Let's bring the 3 dots telling us that the number continues. So being able to identify or differentiate between a rational number helps us to know that rational numbers can be written as a common fraction, while irrational cannot be written as a common fraction. Let's look at the last one for today, which is real numbers. Real numbers. Now you can see that writing the numbers, I've written Q for the rational number, I've written H for irrational number, and I've written R for real numbers. They are the denoted letters for the numbers. So Q represents all rational numbers. H represents all irrational numbers. R represents all real numbers. Then we have the integers being Z. Then we have whole numbers being W, and natural numbers being N. So we'll look at it here where you see and know what we are talking about. So real numbers are numbers that are the set of rational and irrational numbers put together. The set. Remember when we talk about the set, then we are looking at something like this. So when we put a rational number and irrational number together in a set, that gives us a real number. So an example, I can get 3 set to 1 over 5. These are real numbers. Why are they real numbers? Because we have a rational number, which is 3, 1 over 5, and we have this as a what? Irrational number. Good. So when we say real numbers, when we put rational and irrational numbers together, that gives us what? A real number. So this chart briefly tells us or shows how rational numbers, irrational numbers are being related with the what? Real numbers. So real numbers, you have the real numbers being rational number and irrational number put together. So real numbers are denoted by R, rational numbers are denoted by Q, irrational by H. But under rational numbers, we have other numbers in rational numbers. So in rational numbers, we can get integers. What are integers? So we can get positive and negative whole numbers in the integers. So whole number or whole numbers happens to be a subset of integers. What is a subset? A subset is a set whose element can be found in the other what? Set. So if I can get all the elements of whole numbers in integers, then whole numbers is a subset of integers. So we are saying that in real numbers, you have integers. In integers, you have whole numbers. In whole numbers, you have natural numbers. Whole numbers start from 0 to infinity. It has no end. And natural numbers or counting numbers start from 1. Because when you are counting something, you don't start from 0, 1, 2, 3. No. We start from where? 1. So we call them natural numbers, starting from 1. So if this is the chart, then we can say that integers, whole numbers, and natural numbers, these three, they are all subsets of rational numbers. They are all subsets of what? Of rational numbers. So since we understand the irrational, let's quickly look at the relationship between this rational integers and the rest. So we are saying that integers, whole numbers, and natural numbers, they are subsets of rational numbers. So if this diagram, which happens to be, let's say, a Venn diagram, represents our Q, if this represents our Q, which happens to be rational numbers, then we are saying that all the elements here, if they are rational numbers, then in the rational numbers, we can get integers in the rational numbers. So this happens to be integers, which is denoted by what? By Z. Then what again are we saying? Then we said that in the integers, we can get whole numbers. So if I have this as my whole number, denoted by the letter N, then in the whole number, W, then in the whole numbers, I can get natural numbers. And natural numbers are numbers that start from 1 to infinity. And that is what? N. Now this shows the relationship that is existing between natural numbers, whole numbers, integers, and what? And irrational numbers. Thank you very much for staying tuned. So as we said, integers is a subset of this. This is a subset of this. This is a subset of this. And all these three are subsets of this. Thank you for staying tuned. My name is Christian. See you next time. Bye-bye.